Edison, His Life and Inventions, by Frank Lewis Dyer and Thomas Commerford Martin. Appendix 6. The Telephone. On April 27, 1877, Edison filed in the United States Patent Office an application for a patent on a telephone, and on May 3, 1892, more than 15 years afterward, patent number 474230 was granted thereon. Numerous other patents have been issued to him for improvements in telephones, but the one above specified may be considered as the most important of them, since it is the one that first discloses the principle of the carbon transmitter. This patent embodies but two claims, which are as follows. 1. In a speaking telegraph transmitter, the combination of a metallic diaphragm and disc of plumbago or equivalent material, the contiguous faces of said disc and diaphragm being in contact, substantially as described. 2. As a means for effecting a varying surface contact in the circuit of a speaking telegraph transmitter, the combination of two electrodes, one of plumbago or similar material, and both having broad surfaces in vibrating contact with each other, substantially as described. The advance that was brought about by Edison's carbon transmitter will be more apparent if we glance first at the state of the art of telephony prior to his invention. Bell was undoubtedly the first inventor of the art of transmitting speech over an electric circuit, but, with his particular form of telephone, the field was circumscribed. Bell's telephone is shown in the diagrammatic sectional sketch, Fig. 1. In the drawing, M is a bar magnet contained in the rubber case L, a bobbin, or a coil of wire B, surrounds one end of the magnet. A diaphragm of soft iron is shown at D, and E is the mouthpiece. The wire terminals of the coil B connect with the binding screws C. The next illustration shows a pair of such telephones connected for use, the working parts only being designated by the above reference letters. It will be noted that the wire terminals are here put to their proper uses, two being joined together to form a line of communication, and the other two being respectively connected to ground. Now, if we imagine a person at each one of the instruments, Fig. 2, we shall find that when one of them speaks, the sound vibrations impinge upon the diaphragm and cause it to act as a vibrating armature. By reason of its vibrations, this diaphragm induces very weak electric impulses in the magnetic coil. These impulses, according to Bell's theory, correspond in form to the sound waves, and, passing over the line, energize the magnetic coil at the receiving end, thus giving rise to corresponding variations in magnetism, by reason of which the receiving diaphragm is similarly vibrated so as to reproduce the sounds. A single apparatus at each end is therefore sufficient, performing the double function of transmitter and receiver. It will be noticed that in this arrangement no battery is used. The strength of the impulses transmitted is therefore limited to that of the necessarily weak induction currents generated by the original sounds, minus any loss arising by reason of resistance in the line. Edison's carbon transmitter overcame this vital or limiting weakness by providing for independent power on the transmission circuit, and by introducing the principle of varying the resistance of that circuit with changes in the pressure. With Edison's telephone there is used a closed circuit on which a battery current constantly flows, and in that circuit is a pair of electrodes, one or both of which is carbon. These electrodes are always in contact with a certain initial pressure, so that current will always be flowing over the circuit. One of the electrodes is connected with the diaphragm on which the sound waves impinge, and the vibrations of this diaphragm cause corresponding variations in pressure between the electrodes, and thereby effect similar variations in the current which is passing over the line to the receiving end. This current, flowing around the receiving magnet, causes corresponding impulses therein, which, acting upon its diaphragm, effect a reproduction of the original vibrations and hence of the original sounds. In other words, the essential difference is that with Bell's telephone the sound waves themselves generate the electric impulses, which are therefore extremely faint. With Edison's telephone the sound waves simply actuate an electric valve, so to speak, and permit variations in a current of any desired strength. A second distinction between the two telephones is this: with the Bell apparatus the very weak electric impulses generated by the vibration of the transmitting diaphragm pass over the entire line to the receiving end, and in consequence the possible length of line is limited to a few miles, even under ideal conditions. With Edison's telephone the battery current does not flow on the main line, but passes through the primary circuit of an induction coil, from the secondary of which corresponding impulses of enormously higher potential are sent out on the main line to the receiving end. In consequence the line may be hundreds of miles in length. No modern telephone system is in use today that does not use these characteristic features, the varying resistance and the induction coil. The system inaugurated by Edison is shown by the diagram, Fig. 3, in which the carbon transmitter, the induction coil, the line, and the distant receiver are respectively indicated. In Fig. 4, an early form of the Edison carbon transmitter is represented in a sectional view. The carbon disc is represented by the black portion E near the diaphragm, A, placed between two platinum plates D and G, which are connected in the battery circuit as shown by the lines. A small piece of rubber tubing B is attached to the center of the metallic diaphragm, and presses lightly against an ivory piece F, which is placed directly over one of the platinum plates. Whenever, therefore, any motion is given to the diaphragm, it is immediately followed by a corresponding pressure upon the carbon and by a change of resistance in the latter, as described above. It is interesting to note the position which Edison occupies in the telephone art from a legal standpoint. To this end the reader's attention is called to a few extracts from a decision of Judge Brown in two suits brought in the United States Circuit Court, District of Massachusetts, by the American Bell Telephone Company against the National Telephone Manufacturing Company et al. and Century Telephone Company et al., reported in Federal Reporter 109, page 976, a sec. These suits were brought on the Berliner patent, which, it was claimed, covered broadly the electrical transmission of speech by variations of pressure between opposing electrodes in constant contact. The Berliner patent was declared invalid, and in the course of a long and exhaustive opinion, in which the state of art and the work of Bell, Edison, Berliner, and others was fully discussed, the learned judge made the following remarks: The carbon electrode was the invention of Edison. Edison preceded Berliner in the transmission of speech. The carbon transmitter was an experimental invention of a very high order of merit. Edison, by countless experiments, succeeded in advancing the art. That Edison did produce speech with solid electrodes before Berliner is clearly proven. The use of carbon in a transmitter is, beyond controversy, the invention of Edison. Edison was the first to make apparatus in which carbon was used as one of the electrodes. The carbon transmitter displaced Bell's magnetic transmitter, and, under several forms of construction, remains the only commercial instrument. The advance in the art was due to the carbon electrode of Edison. It is conceded that the Edison transmitter as apparatus is a very important invention. An immense amount of painstaking and highly ingenious experiment preceded Edison's successful result. The discovery of the availability of carbon was unquestionably invention, and it resulted in the first practical success in the art. End of Appendix 6.